Good day to you, my dear colleagues. I am recording this additional video today specifically at your request. I will now take the time to answer a number of the questions that you have asked me recently. First question, why doesn't the compressor start from zero pressure? That is, we have air pumped into the receiver. What is this air pumped in for? This air is absolutely essential to successfully kickstart the power plant when there's no external power source available. So taking that into consideration, we always compress and pump air into the receiver beforehand to at least 0.6 megapascals. That is exactly why the compressor doesn't start from zero pressure. Next, you are asking me to explain what this specific metering device is. This metering device is actually a digital multimeter that clearly shows the volts and also shows the amperes. That is to say, it measures electrical flow. It doesn't show kilowatts. Kilowatts will need to be calculated using a formula. Since we have successfully obtained both the specific voltage and the ampere readings from our equipment, we can now proceed to calculate the final power consumption readings in kilowatts. Now we will clearly show you the entire process once again and meticulously record all the power readings the compressor consumes first. And immediately following that, we will move on to show you the subsequent readings that are produced by the system. These refer to the energy consumption readings that an external consumer utilizes. That's it, friends. And now I'm slowly opening up the valve again, and the generation is starting up once more. See, we already have air pre-pumped into the receiver to 0.6 megapascals. And now we have to open up the air supply and the generation process will begin. Electricity generation will start. And using the power from this generation, the compressor can be turned on. I'm starting it right now. There goes the generation. Now the compressor can be turned on. And now let's look closely at the reading. Look closely at the reading. These are amperes. These aren't kilowatts, but amperes. For each phase, the consumption of each phase is shown in amperes. 12.1, 12.8, 11.8. Right now, the compressor is actively consuming the electricity it is generating all by itself. And we also have a furnace connected directly to our power plant, which is equipped with 5 individual heating elements of 2.5 kilowatts each. Let's go ahead and perform the connection right now to see exactly what the readings will be over there. Please carefully observe and take note that right at this moment, an external consumer is already connected to this specific device, which is the furnace we are discussing today. The furnace has a total of 5 individual heating elements of 2.5 kilowatts for each one. The amperes will also be clearly displayed right here on the screen now. Let's go ahead and turn on the furnace. There, take a look at this. Come a bit closer and take a good look. See, these are the heating elements and they are 2.5 kilowatts each, 2.5 kilowatts each. Now, I am turning on the furnace. There, it's starting to heat up. Let's check the reading. Here. The power consumption. Please record the power consumption by the external consumer. These are amperes again. We can see the volts and amperes here. And now we can calculate the total kilowatts using the mathematical formula. I'll write it on the board now, and I'll write down all these individual readings on the board. And we'll calculate together how many kilowatts are consumed by the compressor and how many kilowatts the external consumer uses. I'll write down the readings now. Dear colleagues, here we present the calculation for your attention. By using the specific voltage and amperage readings, we can accurately calculate the consumer's total energy usage within a standard 3-phase network. In this case, this calculation is for the compressor. Here is the formula used to calculate all of this. P equals U times the current strength times cosine phi, where cosine phi equals 0.8. We know the measured readings for each phase, where the measured voltage level is 247 volts. The current strength is represented by I, and the current is 11.3 amperes. So we multiply the value of 247 volts by 11.3 amperes and then multiply by the cosine. By taking into account the power factor represented by phi, the final calculation results in 2233 watts, which is equivalent to exactly 2.23 kilowatts of power. In this way, we calculate for each phase. As you can clearly see, it comes to 223 for the first phase, 254 for the second, and 246 for the third. The total sum of the phases and the consumption. Based on the power consumed by the compressor, we have calculated the total power output to be exactly 7.23 kilowatts. Now, since the space on this whiteboard is a bit limited, I will go ahead and calculate the same values for the consumer unit that is equipped with 5 individual heating elements. I've written the next formula, yes, which can be used to calculate the electricity consumption in kilowatts, equipped with 5 heating elements, which are also powered by our Tribel generator. These heating elements, as you can clearly see here, are connected in pairs. That is 2 elements, then 2 more elements, and finally, one single element is connected separately. So, it forms a parallel connection arranged just like that. Regarding the formula for the calculation of this load, we can apply a standard equation where the power P is exactly equal to U times I, under the condition that the cosine of phi is equal to 1. So we have the phase readings. Yes, the phases, here they are. First we take phase 1, then phase 2, and finally phase 3. We multiply each of these values by the total amperes to calculate the total number of watts, and as we know, we then need to convert the result, well, divide by 1,000, right? And get the kilowatts. And so the total work of the heating elements, the consumption of the elements in the active phase, is equal to 14.85 kilowatts. So it actually turns out that the total power consumption by the 5 individual heating elements is exactly 14.85 kilowatts. And as for the compressor, we can see that the compressor consumes a bit more. The total P value equals 7.23 kilowatts in this case. This is the compressor's consumption. Compressor. There. Esteemed colleagues, I hope that all the points discussed are perfectly clear to you now. If any further explanations are needed, I will be happy to provide them. Thank you very much for your kind attention, and goodbye.